Okay, in the continuing saga of trying to develop this pickup design, choral pickup design, um, I moved to a new software. It's called Inspire, a software I'm pretty familiar with in my job. Um, and it is available to um, robotics teams. So if you want to download it and try it out, perfectly welcome to. I'm more doing this video to demonstrate part of the design process, right? We have um, established our hard points and general linkage shape by um, using Gym and Inventor. And basically, I take this geometry that we've set up, and now I'm going to kind of make it 3D. I'm going to set up some joints, and then I'm going to apply some external loading. And that external loading will be cascaded to each part, where we can do analysis and optimization. Because in general, this part here, I think, can be made a lot with a lot less material, right? So I'm going to go through the processes of how we set up the loading and set up the basically the optimization. And this video is just a little flavor of me taking the geometry, this kind of 2D geometry, and making it 3D. Um, you can really skip this video. It kind of shows you that a lot of the concepts that we learn in Inventor for creating parts are similar with other programs. Okay, so we'll get started. The first thing I need to do, I've imported this geometry. I output it from Inventor as an IGES file. I read it in, and there's a couple of parts that, you know, uh, really have no, um, uh, they're not needed. They're the sketches that I didn't really use in Inventor, and so I'm just going to delete those. I'm going to also go through each one and I am going to color it. So this one, I'll just start off, I'll make this yellow. I'll make the coral um, here. I'll make that, I don't know, orange. The rail, I will make blue. Uh, the inner brace, I will make red. I'll make this part here. Running out of colors. Kind of a reddish pink salmon. I don't know. This one, I will make a light blue. And this one, I will make uh, where green. Green. I don't think I've used green there. Okay. Um, in I've gone through this before. Um, So I've named these parts and such like that. I can also, like this part here, it's it's given everything the default steel. I'm gonna move this to a T6 aluminum. Um, I'm gonna change this part to what I think I probably will make that is some kind of assume that we could print 3D print. So I'm gonna make it, I don't know, ABS. I don't know what printer material is, but it's some kind of plastic. So I'm assuming that the density and the material properties of this generic ABS plastic are similar. Um, I can click the rail and that I'll make aluminum also. Um, I'll keep, oh, this is, this doesn't really matter because I'm just gonna, these are just reference parts. So um, I'm gonna just leave those as steel, but you can see you can go through and very easily change all the parts you want. Um, the first thing I'm going to do is I'm going to take this coral, and we know from the thing, the coral's about 10, 10 about 12 inches long. So this is an inch right now. I will basically create a couple of solids. Extend this solid. So actually, let me grab this and extrude. And you can see this is just like um, what do you call it? Um, Inventor, right? And I'm going to make this 5.5 inches. Uh, the default is in millimeters. Oops, it didn't like that. Let's see. 5.5 inch. There, not inches. Doesn't really care. And I'm just going to say okay. There. And I'll do it for the other side. Um, Again, 5.5 inch. And you can just hit OK there. There's a bunch of ways to hit OK. Now I have three parts, and I don't want three parts. I want one part. So I'm going to go into Boolean. It's in combined. I'll make this the target, and tool is basically the other part you want to combine it with. So I'll combine it with that, and I'll combine it with that. I'll hit the check mark, and now it's all one body. So that's kind of the reference part, right? It's about a foot long. And I will kind of do the same for the rest of these. Here we'll go and we'll extrude this. And this one, we'll just make it as long as this one. And there, we'll go on the other side. We will select that. And, you know, it has similar controls where if you kind of slide the cursor, it, you know, it picks up sometimes you have to position your, um, there. It picks up the, the surface you want to make it equal to. And I'll do it the same for the rail. So the rail, I'll pick this surface and move it out, and move that out to that end there. Then go over here and pick this surface, which is basically a you can have in here, you can have sketches. You can generate sketches just like you do in Inventor. Um, and so the profiles are, I could generate it with a sketch, but since these are already generated, um, I could just pick them. And then we will get rid of that menu. We'll go back to Boolean. We'll select the first part and the other two parts, and we'll hit OK. And we'll select the first, and then, oops, I got rid of the menu. Select the first, select the second, the third, hit OK. Okay, so now I have three parts that have some thickness. I have my two links already in Inventor. I already made this kind of 3D, but I need a bracket for that. And I'm just going to reuse this bracket. So I'm going to copy this, and then I'm going to paste it. And I will just drag it over here and just put it, there for right now. And I'll hit OK. And then I will copy this one, and I will paste it. And I'm going to paste it as an instance, which means any changes I make to one will be reflected in the other. And I'll move that over here and hit OK. I won't do that in this video, but when you see when I go to the next video, these will be modified slightly. I kind of took out the material in the middle, or I took this top off the middle one, and then I took the insides off of these outside ones. So now I've got these, and this one, because of using the CAD software Inventor, this hole's already lined up, but now I need to line these brackets up. So again, just like kind of Inventor, you have some tools to do that, right? I can select this material or this part and move it, and I will take this coordinate system and move it up to the center of that hole. And then take the coordinate system there, get a better view, and I'm going to move that coordinate system to the center of that face. And let's just see if I did a good job. Zoom in and yeah, those holes look aligned. So hit OK. So just kind of position that better, right? This one, I can do the same thing. Um, since these were slid on the rail before, um, when I do this one, I can really just move this up there. And instead of just kind of generally moving it, I can restrict the movement to um, just X. So I can grab this and slide it so that it just kind of touches. Oh, a little too far. Maybe I can't do that. So I'll hit OK once, get rid of that, do the move again, and now grab that point and move it right on the center of that hole. There, and hit OK. Let's see, are we lined up? Yeah, we're pretty lined up. So those holes are lined up, and that'll be important when we put in the joints. So there, now I kind of have 3 brackets. I have some materials set up. I can also um, ground some things. So, these are all floating in space. I can take this and here I can go to motion, which is first me setting up the joints. So in any part of the motion thing, you need to ground certain parts. So this will be ground. Um, so I'll go over here, select that. I can select other parts. The rail will be grounded, and the coral will be grounded. And so then just hit OK. And on the side of this, it shows them with a little ground symbol. And that's all I'm going to do in this video. The next video, we're going to put in joints. We're going to check the motion of this. And we're going to put loads on this. So the reason, again, for doing this is that I have an idea of what kind of loads this should withstand. So in my mind, I've kind of set some targets. And the targets are that when this comes down and engages the coral, it should withstand about 25 pounds worth of load, right? So in a downward force, the load on this should be about 25 pounds. If it gets hit by another robot, I'm going to say it should take about 50 pounds of load. Maybe 50 is a little too high. We'll decide. But a load going along this bracket, 50 pounds, and maybe a load going inside towards the mechanism of 50 pounds. um, or 25 pounds, I'm not sure. So, the larger those loads, the the more structure and the heavier it's going to be. So that's kind of in my mind. We could change them. So that's it for this video. I'll see you in the next one where we add the joints.